Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we are at Sandrini Elementary, home of the Saints, and we're here to do the
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio we have Kaylin with us. And Kaylin, if somebody needs to get a hold of somebody to do the math, how would they do that?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284. Email is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, YouTube, Twitter, and YouTube.
A lot of things right there, huh? All right. Now, why don't you let everybody know where you go to school and what grade you're in?
I go to school at Grimway Academy, and I am in 6th grade.
And Grimway Academy, now I just learned that you have been there for your entire schooling.
Mm-hmm.
And you don't even have to go to school this week, where a lot of other students are at school this week.
Yeah.
So how's that? Pretty nice?
Yeah, it's really nice, actually.
You know everybody else is having to go to school, and you get to hang out for another week, right?
Mm-hmm.
So what are some of the things that you're doing or that you've done over your break?
Just hung out at home.
Just hanging out? You're not doing any like extra homework or anything like that?
Yeah, we have homework packets that we have to fill out over
good.
break. And I've been working on that a lot recently.
And how long does that take? So they know that you've got 3 weeks off, but how long does it really take you to do that?
It would usually take me maybe 3 days to finish if I was going on all day working.
Like a regular school day?
Yeah.
Okay. And is it more difficult work? Or
No, it's pretty simple. You have to read a book, and then you have to write a summary about what you read that day.
what's one of the best books you've read that you've enjoyed so far?
There's a series that I'm reading, and it's called Pegasus.
Okay. And is that, what's that? Does that have anything to do with mythology at all?
Yes.
Okay, well, I kind of thought with the Pegasus name right
Yeah.
there. Well, enough about the reading of the stories and stuff. As fun as that is, you're here to do some math, correct? All right, over to the board, young lady. And I know that you have been working with exponents recently. So up on the board, Devin, if you would, please put up 2 to the 3rd power. And Kaylin, if you would, please explain with Devin what those numbers mean, any vocabulary you know, and how do you do a problem like that? Like what does that all mean? Okay?
So what I know from going to school is that 2 to the 3rd power, is 2 times 2 times 2. So it's 2 multiplied by itself 3 times.
So if I was going to draw this out, let's say I wanted to make a drawing to kind of illustrate what this looks like, what would that drawing look like? What would I draw?
If it were an equation, I would do 2 times 2 times 2.
So this is how we kind of expand this out, right? This is what this is representing numerically.
Right.
If we were to think about this as far as like space was considered, let me put it this way. If I had 2 to the 1, 2 to the 1st power, right? I could think of this like a line that was 2 units long, right? Okay. Let's say I wanted to make this 2 squared. What would that look like? If 2 to the first power is just a straight line, what do you think 2 to the second power, or 2 squared, would look like?
Maybe 2 lines?
It could be 2 lines, but there's something interesting that we kind of mentioned when we said this like this, 2 squared, right? So if this was a square, what would that look like? It would be a square that is 2 across and 2 tall. So how many units would be in the area of this square?
4.
Which makes sense because 2 squared is 2 times 2. So let's go back here. 2 to the third. What would 2 to the third look like? Now, they also call this something else, right? If this is 2 squared, what do we call 2 to the third?
2 cubed.
2 cubed. So this would end up looking like a cube that is 2 across, 2 high, and 2 deep. Now, if we look at the volume of this cube, how many cubes are in this unit?
8.
8, right? We have 4 in this front face here, and we have 4 in the back face here, which makes sense because 2 times 2 times 2 is equal to 8. So there's a couple of interesting things that we can think about here, right? The value of each of these exponents geometrically represents the number of each of the units in each figure. So 2 to the third includes 8 cubes. 2 squared includes 4 squares. 2 to the first includes 2 lengths that are 1 length each. So I'm going to throw a challenge out for you. If this is a cube for thirds, for the third power, if this is a square for the second power, if this is a straight line for the first power, let's keep going backwards. What would 2 to the 0 power look like?
No lines.
It would be no lines, but we have to have something, right?
Right.
So this is a cube, which is basically squares times squares. This is 2 lines, and then this is a line. What is the unit that makes up a line?
1.
It'd be just one little dot, right? And we only have one of those dots, which means that 2 to the 0th power equals 1. And the interesting thing about the 0 power, anything to the 0 power, you get back to that one dot, so it equals 1.
There we go. Nice work with just the initial part of exponents.
There's so much more.
Oh, we've got more to do with that. But it is first now time for today's Math in the News. And today's Math in the News, we're fortunate enough to have somebody in studio with us. We have Jessica Matthews, and Jessica is with the League of Dreams.
Yes, I am.
So why don't you explain to everybody, first of all, what League of Dreams is and your role with it?
Sure. I am the executive director for the League of Dreams, and it is a sports league for kids with disabilities ages 5 to 22. So we offer sports programs to athletes that typically wouldn't have a chance to play sports.
Okay, and is that in Bakersfield only, Kern County, or is it a mix?
We reach all of Kern County. So we are primarily located in Bakersfield, but our athletes come from all over Kern County, including Kern River Valley, Tehachapi, Wasco, Delano, McFarland, Shafter, Arvin, you name it, all of Kern County.
And when people say Kern County, they think, all right, well, you're just taking care of a county, but the county is the size of the state of Connecticut.
Correct.
So it's like you're taking care of a state as far as land area goes and size. How long has League of Dreams been around?
We were first founded in 2007 by Tim Terrio, who is the owner of Terrio Physical Therapy and Fitness.
Okay.
And we have been around for so many years that we now have 5 programs: baseball, basketball, dance, bowling, and we just added another sport.
Ooh, that kind of ties into.
We'll find out a little bit about that.
Yeah.
Now, how many kids do you have?
We started with about 40 athletes in 2007, and now we have over 800 athletes over those 4 primary sports.
All right. Well, I know that we have a little bit of footage that we're going to take a look at right now that will tell us a little bit more about League of Dreams.
Tim Terrio, the founder of Terrio Therapy, had this idea. It was a simple email sent out to Terrio staff that said, I want to start a sports league for kids with disabilities who's in. And now, several years later, we've grown to 4 sports. Our motto has always been every child should have a chance to play. And so we really embody that by giving every child a chance to come up to hit the ball, throw the ball, to pass the basketball, to shoot the basketball, to throw that bowling ball down the lane, to cheer on another teammate. Whatever it is that sport is about, we make sure that they get every single aspect of it. We started a tryout process, and those tryouts were to see what the ability levels were of each athlete.
Now we're gonna walk and dribble all the way towards me. Walk and dribble. We like to make sure that they're paired up evenly so all their skill levels are about the same so the kids can enjoy the game, actually play the game together.
1, 2, 3, Dodgers!
The sky's the limit with this organization.
Never quit. They never quit in life. They never quit doing this. They just always giving 100%. That's a champion to me.
I have always believed in doing what makes you happy. And being around these kids is what makes me happy. You have to see it in person to really, truly understand. It really is life-changing.
It's always nice to have something that makes you happy, so I can see that you truly do enjoy your work. Talk a little bit about your partnership with CSUB.
So we have partnered with CSUB the last couple of years to provide our opening day ceremonies. Our athletes get to go out and watch a CSUB baseball game, and then we do our opening ceremonies, which is our kickoff to the season on their field. It's a lot of fun.
That's a big event out there because I've been out there a few times, and that field is covered with kids that are excited to get going and things like that. Kaylin, do you have a question for Jessica?
Do you have any new sports coming up soon?
Well, I'm excited to say we start fencing for the very first time this weekend. So fencing's our newest sport, and we hope to add another sport soon.
So that's starting up this weekend?
This weekend.
Okay. If somebody wanted to find out more about League of Dreams, where do they need to go to?
OurLeagueofDreams.com is our website, or they can give us a call at our office at 661-616-9122.
Well, Jessica, we certainly do appreciate you taking out some time to come and talk to us a little bit about League of Dreams, finding out some more about it, and especially the new fencing program that's going to be going on.
Yes.
So congratulations on that, and I'm sure I'll see you out at the field at CSUB with the kickoff ceremony and when baseball season arrives.
Absolutely. Thank you for having me.
Hey, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now to head out and about. We'll visit with Marylou and the Saints of Sandrini Elementary.
Thanks, Mike. We are here today at Louis Sandrini, home of the Saints, with the ACES After School program, and we are with 5th and 6th graders today. Woohoo! And we are going to be doing some math. Okay, you guys, you ready? Yeah. We're going to do my favorite math. My favorite math is sometimes people don't like, but I love, and I'll show you why. It's geometry. Yes. How many of you love geometry like I do? Good. I love geometry. Geometry starts in really before kindergarten with shapes, right? Yeah. And then as we get older, we start breaking those shapes apart. And we start learning about the parts of the shapes, yes? Okay, but I want to talk specifically angles. How many of you know what I mean by angles? Come on up here. And what is your name again?
Mason.
Is what?
Mason.
Mason, come here, kiddo. Okay, so I want you to tell everybody what grade you're in. What grade are you
I'm in 5th grade.
Yeah, okay. What's your favorite thing about Sandrini?
The teachers.
Why?
They're all very nice and generous.
And what's your favorite subject?
Math.
Yes. Why?
I've just always enjoyed it.
Okay, so again, my favorite thing's geometry. You raised your hand, you love geometry as well. Angles. Can you give us a little rundown what we mean by angles? What do we mean by angles?
And angles like kind of like where the corners.
Okay, what do you mean? Can you draw? Can you tell us?
That.
So
That's an angle.
where's the angle?
Right here.
Right here. Do you know how to label that's an angle?
Yeah. Isn't it like
Yeah, with a little arc. Now there's 3 types of angles.
obtuse, right, and
Can you draw them for me?
yeah. That's
What would this angle be called?
acute.
Very good. I'm going to write that for you as you say it. Acute, because it's a cute little angle, huh?
Yeah, there's right angle,
Okay.
angle, and then there's obtuse.
So that's a right angle, right? And this is obtuse. Do you know how to spell obtuse?
Yeah.
Okay, spell it out for me. But there's actually a 4th one. This is the 3 main. What's the 4th one? What is that, everybody? It's a what? It's a terrible line, but it's a. But what? Oh, I heard it. What?
I said 180 degrees.
Why? Why is that 180 degrees?
Because it's very flat.
And what is this flat angle called?
It's, I forgot it.
The line is. It's
Parallel?
starts with an S. What?
Straight.
Straight. So this is a straight angle, okay? So again, everybody, repeat after. What is this one, everybody?
Obtuse.
Right angle.
Straight angle.
A what? A straight angle. Okay, so I'm sure your teachers have taught you some hand signals to remember these, right? So acute. Show me an acute with your hand. Kind of like Pac-Man. Ha. Okay. Show me a right angle. How do you make a right angle with your hands? There's lots of ways.
An L?
Yeah, it's an L. Can I do it like this? Yes? Is that a right angle as well? Okay, using your 2 arms, show me an obtuse angle. How can you do obtuse? Wow, lots of different ways. Am I an obtuse angle?
Yes.
Am I an obtuse angle?
No. Yes. Yes.
Am I an obtuse angle?
No.
Am I an obtuse angle?
Yes.
What am I now?
Straight angle.
How else can you show me in a straight angle? There you go. Show me again. Boom. Yes. Like that. Ooh, I like that one. Pew. Chop. Okay, so this is what our focus is today. We're going to talk about how to find angle measurements. Okay, so we have a lot of work that we are going to get started with, but for right now, we're going to take a break and we're going to head back to you, Mike, in the studio until we come back, and we're going to have more work with these angles. So
All
back
right.
to you.
Thanks for that, Marylou, and it's always good to have more work. As a matter of fact, we have more work for Kaylin right now, 6th grade student from Grimway Academy, who has this week off again, but not totally off because you're here doing math work, right?
Right.
All right, back over to the board, young lady. And we'll continue with the work that you started with exponents. So between you and Devin, I would like you to come up with a multiplication problem where you're dealing with exponents.
Okay, so let's see if we can multiply some sort of exponents. We did 2 to the 3rd before. Let's come up with a different base and a different exponent. You do the exponent, I'll do the base. Ready?
Got it.
I'll go with 5. What do you want to be as the exponent?
I'll do 4.
So let's go 4. All right. So when you looked at 2 to the 3rd power, you expanded it out as a multiplication sentence. Could you do the same thing with 5 to the 4th here? Mm-hmm. So you're representing this as the number of times the base is multiplied by itself. So we are multiplying 5 4 times. So how would you sequence this? Would you go one at a time? Would you group them together? What are some approaches you'd take on this?
I would group them together.
Okay, so how would you group these together?
I would do 5 times 5 here and 5 times 5 here.
So for each of these you get 25, and you end up then multiplying 25 times 25. Now that's kind of interesting. If you notice, this ends up being a a square. So what we're really saying is 5 squared is equal to 5 to the 4th. So this is an interesting property that we end up discovering as we explore. But anyway, for these two, we end up multiplying 25 by itself. So when we do 25 times 25, where do we end up?
Let's see.
We have 25 times 5 ones, and then 25 times 2 tens. So 125 plus 500, that gets us to 625. So we know that 5 to the 4th power is equal to 625. Okay, pretty straightforward. Now, let's say, because I want to explore this idea a little further. Let's say we have 5 to the 8th. What would that look like? Or how would we write that out? So this is going to be, I'm going to guess, 8 fives, right? So we got to kind of count this. But what's interesting is, as we've done that, maybe we put one right over here in the front so that we can kind of keep that space here. Is this strategy of grouping things together, since we've already found what 5 to the 4th is, could we do the same thing over here? Because we already have two groups of 5 times 5 times 5 times 5. So this ends up being 625, go ahead.
Times 625.
So this times itself. So 5 to the 8th ends up being 5 squared, squared, squared. It's a good thing these shows have time limits, otherwise we would be doing this all day. But this is a really interesting pattern that we start to notice as we continue to play around with exponents a bit more.
Good. And before you continue, what I'd like to do is just show you a little, it's not a trick, but an easier way for you to multiply when you have 25s and 35s and things like that. So up on the board, you saw that 5 to the 4th was 5 times 5 times 5, which is 625, right?
Correct.
Okay. So what I want you to do is leave that up, and maybe where you multiplied 25 times 25 underneath, get rid of that and your 5 to the 8th off on the side.
All right. Let's
So
go ahead
this way
and
we
do
give Kaylin a little bit of
big
place to
circle
work
and
with
then
here.
Tap in the middle. Okay.
All right. So what I want you to do is think with me right now, okay? So if somebody said, what is 25 times 25? Now you could do it in your head. It's going to take a little bit of time and it's easier to write it out, correct? Mm-hmm. Think about this. So write down 25 times 25. Okay, now we know that it ends in 5 times 5. So we know the answer is going to end in 25. All right?
Got it.
So next to that, put equals. Now write down the first number that you wrote, 2, times, what is the next number after 2?
3.
3, so write down 3. What's 2 times 3?
6.
So write down a 6. And we know that 5 times 5 is what?
25.
So put the 25 after the 6. So what's 25 times 25?
625.
Okay, now let's see if you got the pattern here. Somewhere up above that, put 35 times 35. Okay, now let's follow the pattern. Okay, that's going to equal, so put your equal sign. What's the first number you wrote?
3.
3. So put 3 times, what's the next number?
5.
No, after 3, what comes next?
3.
Well, look, when we wrote 2, the next number after that was 3, right?
Think about the counting sequence.
So
1, 2,
3, what comes
Oh,
next?
4.
There you go. Now, what's 3 times 4?
12.
So write 12. What's the answer going to end in?
25.
So the answer is 1225, 1,225. Do you see the pattern? Now, what I want you to do is I want you to think. Don't write it, okay? Put 45 times 45. Now, in your head, tell me what you're thinking and how you can do this in your head now.
Okay. So the first number that I put was 4, and the next number in the sequence is 5. So 4 times 5 is 20. And then we know we add the 25 to the end.
So write the answer. What's the answer going to be? You see how easy that is?
Mm-hmm.
All right, try this. 75 times 75.
On the board?
Go ahead and write it down.
Maybe not.
75 times 75. Now, a lot of people will go, 75 times 75, that's going to take a lot of work to do that. You do it in your head, though. Explain how again.
So first number we put, 7. Next number in the sequence is 8. 7 times 8 is 56. And then we add 25 to the end.
Now, just to make sure you're doing this all correctly, here's the calculator. I want you to go ahead and check it. So put in 75 times 75 just to verify that you're getting all these correct.
Yep. 5,625.
So that's a nice little pattern, right? If you know the patterns, sometimes you can see little ways to get around them easier to solve problems quicker. Because you will take standardized tests, right? And you're going to have options, right? You have like A, B, C, or D, right? You get questions like this, and if you see the patterns, you can get through without even having to write out the whole problem, right? You can just look, oh, it's going to end in 25. 7 times 8, 57, I'm done, right? And the teacher's like, how'd you get done with that already? It took you 3 seconds. And you're like, remember the old men on Do the Math. They told us about these little tricks and patterns and things like that. So nicely done on that. So go ahead, clear the board if you would. And while you're on exponents, I know that you've been talking about in science class, you're doing math in that also, right? So why don't you and Devin talk a little bit about scientific notation and where exponents comes in with that.
So there is a lot of really interesting things in science that are universally large or microscopic small. They're values that are so big that we really can't fit them on a board, or so small that they would have so many decimal places that we'd run out of space. So what they'll do is they'll use something called scientific notation. So for example, if we're talking about the distance from the Earth to the Sun, it's about 93 million miles. Yeah, we could write down 93 million as a number. It's going to take a long time. However, what we also recognize is that 93 million is equivalent to 93 times 10 to the 6th power. 93 millions, right? Which is also equivalent to 9.3 times 10 to the 7th. So 10 million times 9.3. What this allows scientists to do is represent extremely large values or extremely small values with as little space as possible so that they can focus more on processing numbers. So we can take a really large number and represent it or estimate it based just on scientific notation. So for example, let's see if we could find a way to represent, we'll work small here. Let's see if we can represent 43,000 using scientific notation. So the first thing we want to represent or find out is what multiple, what power of 10 should we use? Now if you notice, kind of a pattern here, 9.3 times 10 to the 7th. Let's count and figure out how many spaces we go until we get to the decimal point here necessary, right? So let's start here all the way before the ones place. Go.
Got it. 1, 2, 3, 4, 5, 6, 7.
7, right? We ended up moving that decimal 7 places to the left in order to get to this 9.3 represented here. So let's see if we can do that here at 43,000. Let's go.
1, 2, 3, 4.
So I should stop right there, right? Okay. So what is the power of 10 I'm going to use in this representation?
4.
So this is 10 to the 4th. Now, the base factor here is going to be where I ended up with our part here. So that's going to be 4.3. We can represent 43,000 as 4.3 times 10 to the 4th. Now obviously, yeah, we can write these numbers very easily, but this is just kind of a model. If we wanted to do quintillions, or if we wanted to go into like trillionths of decimal places, that's when those exponents would come in very, very handy.
So you get very large, very small numbers easier to manage like that.
Absolutely.
Nicely done with the work on exponents, and for your great work on exponents, you've got yourself a couple of tickets to any sporting event courtesy of our friends at CSUB Athletics. So congratulations on that. Hey, we do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this. Today we're at Branch Elementary, home of the Mustangs, and we're here to Today we're at Branch Elementary, home of the Mustangs, and we've got some 6th grade students. We're going to work on some order of operations. You guys ready? Mm-hmm. So first of all, tell me what you know about order of operations.
Well, I know that you do it's like PEMDAS. So you do parentheses, exponents, multiplication, division, addition, and subtraction.
Okay, so there's a certain order in which you have to do things, right? Which is why it's called the order of operations.
Yes. Mm-hmm.
Now, you said PEMDAS, right?
Yes.
And what does that, other than I almost gave it away, right? Mm-hmm. Parentheses, exponents, multiply, divide, add, subtract. Have you ever heard some other saying to go with it?
Please end my day at school.
So instead of please excuse my dear Aunt Sally, which a lot of people, have you ever heard that one?
Yes.
So please end my day at school.
Yes.
You guys have that much fun at school? That you're just waiting for the day to end? All right, let's move on. So this will be something a little different. Now you guys are all familiar with order of operations.
Yes.
Okay, and you know there's a certain order in which you need to do things. So here's what I'd like you to do. I'd like you to write down this problem. 2 times 2 plus 0 times 4. Now, what I'd like you to do is I would like you to solve that problem. All right, go ahead. So evaluate what 2 times 2 plus 0 times 4 would be. And we'll see if you guys come up with the same answer. And if so, great. If not, we'll see what the answers are and how you came about those answers. All right, so Kaylin, let's start with you. What did you do first?
So first I knew 2 times 2 is 4,
Okay.
and then plus 0 is 4, and then 4 times 4 is 16. So
Okay, so you went right across,
Yes.
right in order, all right? What about you, Cameron? Did you get 16?
Yes.
Okay, and what did you do?
I did the same thing. I did 2 times 2 equals 4 plus 0, and then I multiplied that by 4, and I got 16.
So you went straight across also. All right, Priscilla, you have something different. You
Yes.
have 4.
Yeah, so what I did was 2 times 2, which equals 4, and then I did that plus 0. No, and then I did 0 times 4, which is 0. Then I did 4 plus 0, which is 4.
Okay, so we have 2 different things here. So which one do you guys think is the correct answer after seeing 2 different answers? Because those are the 2 answers that most people come up with all the time. Which one do you think is correct, 4 or 16?
Probably 16.
16.
Now, why do you say 16?
Because
2 of them have it?
Well, no, because
Okay.
you do multiplication, but also sometimes you're supposed to go from left to right if it doesn't have any parentheses.
Right, and we are supposed to go left to right, but we always do multiplication first, right? So you know you have to do the 2 times 2 is 4, right? Is there any other multiplication?
Yes.
What is it?
0 times 4 is
0 times 4 is 0, so the answer should be
4.
4.
Or,
Do you guys see that now?
I got 2 different answers. I got
Right.
4 and 16.
There you go, because I saw you get 4 and then 16. I was like, oh, which one do you want to go with? So there we go, a little introduction with the 6th grade students at Branch on the order of operations. And once again, a big thanks to the Mustangs. Staff and students had a great time. We were able to visit out there. We do have phone tutors available. 636-4357 is that phone number. But right now, we do have another opportunity to go visit the Saints at Sandrini Elementary.
Today we are back here at Sandrini Elementary with the ACES After School program, and I'm with 5th and 6th graders, and we are talking geometry today, okay? So we talked about what the angles look like, but what about measurement? Sir, over there, you said that this is 180, right? Yes. Okay, so that's a straight angle. We know that that's 180. If this is 180, then everybody, what is a right angle then?
90.
What?
90 degrees. 90 degrees.
Because it is what in comparison to a straight angle?
Half.
It's what?
Half.
It's half. We know that 90 is half of 180. So if we went 90 plus 90, we're going to get?
180.
We're going to 180. However, in obtuse angle, do we know what that measurement is?
Above 90.
It's what?
160.
It could be.
It's between 180 and 90.
Is it equal to 90?
No, it's between 180 and 90.
So you're telling me that it has to be greater than 90?
Yes.
Can it be 90 and 5/10?
No. Yes.
Is that greater than 90?
Yeah. Yeah.
Is 90 and 5/10? Yeah. Can it be 181?
No.
That's too big?
Yes.
Okay. Okay, so we know that this has to be, it has to be somewhere between, it has to be greater, the angle has to be greater than 90, but we know that it has to be less than 180. Yes?
Yes.
Fair statement?
Yes.
So can you, looking at this statement that I made, what statement can we make about acute angles?
It can only be 90 degrees.
Only 90 degrees? Remember, acute, it has to be less than, so our angle has to be less than 90 degrees. Oh, I know I'm bad, huh? I didn't put my degrees on there. Thank you for reminding me. It has to be less than 90 degrees, but can it run into negative numbers?
No.
No, that doesn't make sense, does it? It can't run into negative numbers, really, right?
No.
So it has to be 0 or greater, right?
Yes.
So it has to be greater than, did I do that one right? Or does it go the other way? Oh, the other way. I know. I think it goes that way, yes?
Yeah.
Okay. All right, so we're going to do some angle measurements. You ready? On your board. Here we go. Yes, you guys are ready to work, huh? Okay, so I want you to first draw me a 90-degree angle. How do we know it's 90 degrees? Geometry is about facts. We have to, why? How do we know? What do we do?
It would be squared by the edge of it.
Very good. We need to draw a little corner, okay? Geometry is about facts. Always remember that. You have to prove it. You can't assume. We have to prove it, okay? So we know that that's 90 degrees. Now I want you to draw another little angle off of it in the side like this, okay? So I created an acute angle inside my 90 degrees. How many acute angles do I have inside that 90 degrees? Two. Okay, so I want you to put the variable x on the top acute angle, and I would like you to put 30 degrees on the bottom angle. Show me that you're ready to go. I want to make sure we're all good to go. Thank you. So, who can predict what I'm going to ask?
Ooh,
What do you think I'm going to ask?
You're gonna ask that what the x would be.
What do you think I'm going to ask?
What measurement the x is?
Anybody else?
What the number of the x is? What's the point of the x?
I really like what everybody said. And whatever those people said, what is the x? Yes. What is the point of the x? Yes. Can I throw in one more? Yes. Write me an equation. I would like you to write me an equation that matches this. Write me an equation. Then I want you to solve that equation. We good? Yes?
Yes.
Okay. Share with us what your thinking was.
I thought that since it's 90 degrees and you put 30 degrees, the answer would be 60 degrees because 30 and 60 is 90.
Okay. Could you double check your work to make sure that that is correct?
Yeah.
How can we double check our work, guys? How can we double check our work?
By adding 60 with 30.
How many of you double checked your work? Anyone double check it on the board, showing that you checked it on your board? Do that now. If you have not double checked your work, let's double check our work to make sure that that x equals 30 degrees. So right here, you had it, right? Real quick, we have 30 plus 60 equals 90. Okay, so we are going to be coming back in a second, but when we come back, we are going to be adding on to this even more with geometry and angles. But for right now, we're going to send it back to you, Mike, at the studio.
All right, thanks for that, Marylou. In studio, we have Kaylin with us, a 6th grade student from Grimway Academy. And as a matter of fact, you are the first student to be on Do the Math in the year 2020.
Wow.
Happy New Year. And when Jessica was in, she was asking how long Do the Math has been on. Do the Math has been on since 2001. So it's kind of a Happy New Year, continuing in our 18th, going into 19th season right there. So a lot of things happen with a new year. What's one of the most recognizable things that you can think of that happens on a new year?
Just a lot of people being excited for a whole new decade this
Everybody's
year, too.
excited, right? So you've got a new decade also, right? Now, do you stay up until midnight to celebrate the new year, or do you do it like us old men and we celebrate like back in New York at 9 o'clock where we're from? And
No, we stay up until midnight.
so you
at
stay
our
up until
house.
midnight. And you get all sorts of party going on, all sorts of noise
We
and
had
everything going wild and
sparklers.
crazy.
Yeah, we had
Oh,
sparklers.
so you're doing everything up, huh?
Yeah.
I mean, you can party at 9 too. I'm just putting that out there. It's very reasonable.
Well, you know what? Since it is 2020, and one of the big things is everybody gets together and they wait for the countdown until midnight actually happens, and you ring in the new year. So there are a lot of students working on math counts, which is a pretty big deal across the country, where it's a high-level competition for 6th, 7th, and 8th graders. So there's 6th graders competing with 8th graders, and everybody's in it together. And this is one of the problems that the kids at Math Counts are working on. It happens to do with the New Year, so we're going to have you work on this also. All right? So let's take a look at the problem together, and we'll see how you and Devin want to solve this. On New Year's Eve, the ball will begin its descent down the 77-foot flagpole at Times Square at exactly 11:59 p.m. So it's going to start at 11:59 p.m. It's going to go down 77 feet. So that way it will hit the mark at exactly 12 o'clock midnight. The question is, how many inches does the ball fall every second?
There are a lot of little elements to this one. Could you bring that problem back up here for us just for a moment so we could really like deconstruct it and parse it? So when I see problems like these, I know generally the approach is, well, let's just find all the numbers and then find all the important words. But here's where they get you. Not all those values are important numbers to us in this problem. And not all those words are aligned. The important thing to understand is what we need to find. So starting off here, what do we need to find in order to be successful with this task?
We need to find how many feet it falls.
Is that what it says in that question there? How many feet it falls? Take a look at that last question, because that's ultimately what we have to be able to report as our answer. So go ahead and read that question. Not the whole thing, just the question part, that last sentence.
Oh,
let's go ahead and get it back up there.
Again. Hey, you know what? I'll just hand it to you. That way you can just look at it.
So, we got to still, that.
How many inches does the ball fall?
How many inches? A lot of problems throw that to us, right? It's asking us how many inches does the ball fall at, and what is the unit that we're using? Is it per minute, per hour?
Each second.
Each second. Let's go ahead and make sure we get that down. How many inches each second? Now, there's another interesting part of this problem. It doesn't seem to mention anything about inches or seconds anywhere else in the problem, right?
Right.
So we have to look for other types of clues that might help us out here. So let's go ahead and read again from the top. And I want you to stop me and like yell at me. Like don't just like say like, oh, could you please like you like point in my face and be like very aggressive about it. As soon as I say something that might be a helpful clue. All right?
Got it.
On New Year's Eve, the ball will begin its descent down the 77-foot flagpole atop 1 Times Square at exactly 11:59 p.m.
Stop.
Well, okay, what did I say?
That it's going to fall at exactly 11.
Okay, so at 11:59 p.m. Okay, can I keep going? I'm going to ask very kindly for permission. And it'll reach the numerals 2020 at exactly 12 o'clock midnight on New Year's Day.
Stop.
What did I say now?
That it stops, that it falls, it lands on the ground at exactly 12 o'clock.
Okay.
12 a.m.
12 a.m. So we've got to figure out how much time is between these two moments here. So how much time is there between 11:59 p.m. and 12 a.m.?
1 minute.
1 minute.
60 seconds.
Oh, okay. So that's good. Which means this is going to fall for 60 seconds. Now, we got to find out how many inches it falls each second. I don't remember it saying anything else about inches in this problem, though. I have to read it again, don't I? Oh, man. Okay. On New Year's Eve. Okay. The ball will begin its descent down the 77-foot flagpole atop...
Stop.
Okay. What was it there?
77 feet.
77 feet. Okay. That might be helpful. But how am I going to use 77 feet?
To convert it to inches per second.
Okay. So what you're saying is we've got to figure out how many inches are in 77 feet.
Right.
So how would we figure that out?
I would figure it out by doing 77 times 12 because there is 12 inches in a foot.
So 12 inches per foot times 77. So we'll do this. I'll go ahead. You've been doing a lot of the yelling and pointing, so I will just continue to do whatever you say, and I'm going to presume that you're to tell me to do the multiplication here. That's going to be 15, and now I'm going to go ahead and take care of the ones column here. Thank goodness that's just by ones. So we have 944 inches. We know it's going to fall 944 inches in 60 seconds. So how am I going to figure out how many inches it's going to fall every second?
What I would do is I would divide 944 by 60.
Well, we're going to go ahead and let you do that then if you would. She said she would. 944 inches divided by 60 seconds. And that's going to tell us how many inches per second it's going to fall. So go ahead and kind of talk us through this as you work through it.
Got it. So I know that 60 does not go into 9, so I have to move on to 94. And I know that goes in once. 60 times 1 is 60. Subtract that is 34. Mm-hmm. Then you bring down the 4 because 60 does not go into 34 evenly. And 60 goes into 344 5 times. So 60 times 5, well, I know 6 times 5 is 30, and then you add a 0, which is 300.
Okay.
Subtract that, which gives us 44. And then 60 does not go into 44 evenly, so we have a remainder of 44.
Ooh. So we can say 15 and 44 sixtieths of an inch every 1 second. Because that's really what that remainder represents. It's how many of the last group is left before you can fill one out. Now you could also represent this with decimals, but you're very precise here. 15 and 44 sixtieths of an inch.
And what I'd like you to do is actually take that and turn it into a decimal now.
You heard the man, he said to turn it into a decimal. Now, do you know how we can proceed through there and do that?
No.
Well, it's a good thing we explored decimals when we talked about scientific notation because there is no shortage of place values. We just have to make sure we go into the decimal zone and continue by doing such. Now, what's going to be in the next place value over here after the decimal?
0.
0. So now we can go ahead and bring that down. 60 into 440. How many 60s could we cram into 440?
7.
We can do 7 because that'll get us to 420. We might be working for quite a bit on this because I think we're starting to reach
Round it to the nearest tenth.
Well, and I think we've just about got it. We'll have 20 left. We have another decimal value. So let's just move that over here, 200. How many 60s into 200?
4.
So 60, 120.
3.
Now if we go ahead and that's going to give us 20 more, this is going to keep repeating forever.
Right.
So if we round this to the nearest tenth of an inch, is this going to stay at 15.7 or is it going to round to 15.8?
15.7.
Okay, so we are more than happy rounding it to 15.7 inches every second.
And I like the 4460 is more precise.
Absolutely.
As an answer right there, so nicely done. For your great work right there, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. Hey, we do have phone tutors available until 5:30 this afternoon, as we do every Tuesday and Wednesday, most of them throughout the school year. But right now we have one last opportunity to visit the Saints at Sandrini Elementary.
We are back here at Sandrini Elementary School, and I am with the 5th and 6th graders of the ACES After School program. And we have been doing what, everybody? Geometry. Geometry. We're having fun, aren't we? Okay, real quick. That equals what?
180 degrees.
That equals?
90.
Just knowing these two things, we will be successful. So we just solved a problem. We found a missing angle measurement with 90 degrees. Now what I want you to do is erase your boards real quick, okay? Let's do that. Okay, so here's our problem. We have a straight angle. Do you guys see your straight angle? Draw it for me. We have a straight angle. And I have an acute angle and an obtuse angle. I need you to do two things. One, you're going to find the measurement of x. And then 2, you're going to find the total measurement of that whole angle here. Okay? So how many things do you have to do? 2 things. Okay? It says x plus 62. Okay? So we need to find out what the variable is, the missing number x, but we also need to find out what that whole angle measurement is, because x is just not that measurement. Because we also have what added to that x. We have 62, okay? I'm gonna let you collaborate on how you could come up with an equation, solve for x, and find the whole missing angle measurement. So I'm gonna let you guys talk this through, okay? All right, go. Talk it through with your partners. Ladies, what's your first thinking?
How do we find this and what question?
Okay, so what information do we have for sure that we know?
This is 180 and this one's 30 degrees.
Okay, how can you use that information to help you?
Subtract 30 from 180.
Okay, all right, start there. That's a good thought. Let's go over here and check on these gentlemen. Gentlemen, so what's your thinking?
So we're gonna add the what we know, which is the acute and the right angle,
or the obtuse.
Yeah, the
Okay.
obtuse. And I'm adding it up, and I got 92. So I'm thinking if we get to we can see if the answer is.
Okay, so we also have that x. So what are you saying this 92 then equals?
We'll try. If we add a certain number to the 92, we will get 180.
Okay, keep working. Keep working. I like where you're going. Let's go over here to this group over here.
Add this one like that.
What is our thinking?
So we're thinking that we could add 62 plus the 30 degree on the bottom. We could add that, then use the number that we get from the 30 and add it and subtract it with 180.
What will that equal? By getting this answer, what is that information?
The information is...
Is that the x or is that the whole angle measurement?
The whole angle and...
Okay, keep working. Let's find out if you're right. Okay? Okay, let's go over here. Gentlemen, this group. Have we already solved it?
Yes.
Explain, sir.
So I made the equation. I put x plus 62 degrees equals 180. And I put x equals 118.
Okay.
So then...
My question to you is, are you telling me that this whole angle here is going to equal 180?
Yes.
Okay, this angle right here? Or is it this angle and this angle equals 180?
Both of them.
But this isn't 62, this is 30. So this measurement should be x plus 62, right? And this angle is 30. Okay, so fix that real quick and keep working because you're doing a really good job. Gentlemen, did you solve it? Okay, let's find out.
So what we did was, since we know this is 180, we added 30 plus 62, which equals 92. And we subtracted 92 from 180 to get 88, so x equals 88.
Okay, that is x. So what do we do to find out this whole angle measurement? What do we have to add to 88? Okay, add that for me real quickly.
Oops.
150 plus 30 is?
180.
Nice job, and there you go. All right, you guys, I first want to thank you so much for letting me come here to Sandrini. You guys have done an awesome job. I am hoping that my love of geometry has rubbed off a little bit on you guys because I do love it, and it's all about the facts. And again, thank you to the ACES program for letting us come. And that's it for today from Sandrini Elementary. We're sending it back to you, Mike, at the studio.
All right, thanks for that, Marylou, and also thank you to the Saints of Sandrini Elementary. We do have phone tutors available until 5:30 this afternoon. A big thank you to Kaylin, a 6th grade student from Grimway Academy, coming in today. What's one thing that you learned today?
I learned that it's easier to multiply numbers with 25s, 75s, 35s.
Oh, so that's something that you learned today. So even more important than that, did you have fun today?
Yes, I
Good.
did.
Well, that was the goal right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.